Good afternoon, everyone. My name is David Lindeman. I'm Director of Health here at Citrus. Delighted to have you all join us. And again, welcome to our campuses who are web viewing today. Folks at UC Davis, UC Merced, and UC Santa Cruz. We're delighted to have you folks join us as well. As you know, we have our Wednesday research exchange every week. We have a great treat for you today in terms of very interesting innovation and technology. But before we get started on that, I'd just like to share just a few quick comments. First, as always, we use compostable items for our lunches. So if you would, we have recycle in the back. We're also asking that we're always hoping that we do not have interruptions for our speaker, who will go for the next half hour. We'll have a wonderful opportunity for questions afterwards and be able to join the speaker for additional questions at 1 o'clock. We have one major event coming up, which we be thrilled if you be able to attend and are interested in. Citrus and the Bonato Institute and Microsoft will host a symposium. It's going to be May 10th right here, and it's dedicated to exploring the effects of AI-enabled technologies on labor, law enforcement, and public services. So Inclusive AI is the title of our program, and you can pull it up at either the Citrus website or inclusiveai.eventbrite.com. So with that, we're ready to start our program. I'm thrilled that we have colleagues here today from Zipline International. Keenan Wyrobek is co-founder and head of product and engineering at Zipline International, and it's the world's first drone delivery service whose focus is on delivering life-saving medicine to the most difficult places around the world. Here at Citrus, you may know we do a great deal of work with vulnerable populations at remote locations, our telehealth programs and other research, and we're thrilled to be able to support this today. Keenan received his master's in mechanical engineering from Stanford and is being joined by his colleague John Schwinnett from Zipline International, and they will both present and take your questions. And without further ado, the floor is yours.
So just to introduce John a little bit more, John is part of our flight operations team, and we'll talk about it a little bit later, but stood up the distribution center in Rwanda and trained the team that's now running it. And so I plan to keep this pretty casual, so anyway, if you have questions, let me know. I also set up this tool I've never used before. If you go to that URL in the bottom left corner of that first slide, you can type questions in or vote questions up, especially for those who are remote. If you want to get questions in, you can do it that way. I'll put that URL up again at the end. So super excited to be here. He did a good job of introducing Zipline, but the Zipline is the first delivery service using drones to operate at a national scale, and we're focused on basically delivering medical products in the parts of the world that are very hard to access. And we do this with small autonomous vehicles, like the Zip, we call them Zips, the Zip you see there in that image. This started about 3 years ago when we met a group of researchers at the Ithaca Health Institute in Rwanda, in Tanzania, and they had done something really impressive but also scary. They had gone out to doctors in the rural areas of Tanzania and asked them to text them every single time they didn't have the medical supply on hand they needed to treat a patient, including blood, pharmaceuticals, vaccines, and even just really basic medical supplies, bandages, things that we would consider very over-the-counter. And they very quickly compiled this massive database, and they showed it to us. And a huge part of that database was basically cases where they needed a medical supply like blood to save someone's life, and they simply didn't have it. That's really where this all came from. Looking at this database that was really this database of death, and sort of realizing that we could really solve the problems that lead to this challenging supply chain with drones like this. And so that's where this was born, and we've been working ever since to make this happen. We've been operating in Rwanda since October, and I'll take you sort of through that. So just to put some numbers behind the challenge, this is obviously focused on children, this first stat, but World Health Organization estimates that 5.8 million children die every year due to lack of access to basic medical products. That's almost twice as many kids as are born in the United States every year. It's a big number. In a lot of these developing world countries that lack basically paved roads and bridges and have rainy seasons that are up to 9 months of the year, it's just a logistics nightmare trying to get vehicles through. I thought I'd share a couple more pictures. This is a picture from a few years back when we were traveling to one of our customer countries. Here's a few more just to give you a sense of what this looks like. That's a pretty big truck trying to basically get through a road. You can get a sense of what a good bridge looks like in some of these areas. And that's obviously a pretty precarious situation to get through. And the net result is that trying to run a reliable supply chain out to these clinics with trucks or motorcycles, basically no one's figured out how to do it and actually do it in a way that really has super reliable supply and super responsive supply. Let me jump into our deployment in Rwanda. We've been making deliveries in Rwanda since October. Our distribution center is the little Z in the middle of this map here. And we've been basically bringing on hospitals, which are the little drops of blood symbols, ever since, that we basically deliver to all day. We'll be scaling up to deliver to all of the hospitals you see mentioned here. There's 21 transfusing facility hospitals, and we're exclusively delivering blood to them and blood products. So this is red blood cells, plasma, platelets, different types. We're doing this to basically enable dramatically more efficient use of the blood supply in Rwanda, and to really close any gaps that might be there. And getting that blood where it needs to be, which has obviously aided a huge amount by doing this in a very on-demand fashion. For those of you who aren't familiar with blood and blood products, their shelf life ranges from 5 to 40 days, right? So from the time of donation, you got to get that blood to a testing and typing facility, which in Rwanda is in the capital city, and then it has to get back out to the point of use. It's a scarce commodity like it is everywhere in the world. And so being able to use that much more efficiently, and then of course make deliveries rain or shine, is basically the service we provide to the Rwandan government. How it works, super simple. We get orders from the lab techs and sometimes even the doctors at these hospitals. They can do it by web form, by WhatsApp, by text, by phone, and they all have their preferences of how they get it to us. We maintain stock of blood at our distribution center. Our technicians basically pack that blood, or those blood products as needed, into the package. You can see the little picture. We put it into a zip and it flies out. The zip flies automatically out to the facility where it drops the package into the yard of the hospital. And then the zip turns around, flies back to our distribution center, and we send it off to the next delivery. And so this is basically it's obviously pretty simple. This is the cycle that's running on demand out of our distribution center in Rwanda. Our fleet in Rwanda just grew from 8 planes to 14 planes. Let me show you what that looks like. So this next video here, this video here is a plane making a drop in slow-mo. So you'll see it drop right in front of the lab that requested that blood. So that building down there is who wants it, and that's the delivery. Anyway, so it's dropping from about 30 feet in the air, as you can see. The zips are measuring the wind speed and direction very carefully before they make the drop to make that drop as accurate as we can to get that blood where they actually want it on the ground. You can see the women in the foreground are a little stunned. This was actually the first delivery made to that hospital. This is a little surreal when you first experience this. Yeah, we do both, for a little context, we do both what we call routine and emergency deliveries of blood. So basically what that means is for very common blood products, essentially red blood cells of common blood types, we maintain a stock at these hospitals. So basically they maintain a small stock. When that stock runs low, they place an order with us and we get the blood out to them. And then we also do emergency deliveries, which is basically either something catastrophic has happened, like a car accident where there's basically a lot more demand for blood than they have in their stock, or for rare blood types and less commonly used blood products. So things like plasma, platelets, and rare blood types of blood. We deliver emergency deliveries, which means the patient's already there and needs it right now. This is a little flyover of what our distribution center looks like. I'll intro it before the flyover happens, but basically on the left you'll see some videos more of this later. That's where we land the zips. In the middle, there's we call it our controller tower, and the tent, which is basically where we do our operations from, or under, and the launcher's on the right. So here's a little tour of that. This is the video we made when this was first getting built. You saw a guy rebuilding a launcher. There's a plane on a launcher on the right there. And under the tent, you'll see. These are pre-flight test stands. Basically, before every single flight, the plane goes through a thorough automated and manual checkout process. These are their first few weeks of building this distribution center, so there's still a lot we're setting up in this video. There's a zip going outside into a storage rack. And he's pre-flighting a plane on the launcher. So there's a last checklist he'll go through before that zip is sent off. So on the flight, so we think of our operations sort of two teams. There's a flight operations team that's 2 to 3 people. This is our zip controller, the person who's overseeing the fleet of planes in the air, as well as the people handling the planes, turning them around. And we have a separate team that works inside. If you saw in that little walkthrough under the tent, there were some containers. One of those containers is basically where we have all the blood storage. And our blood handling technicians prep the orders, get the packages packed in that clean environment. And they hand it out to the flight operators who put them in zips and send them on their way. We're working our way up to 150 plus deliveries a day at this distribution center. Our peak so far is just shy of 30 deliveries in one day. Our partners estimate that each plane will save about 8 human lives during its service life, just to kind of give you a metric for how the customer has made this purchasing decision. By the way, John, feel free to pipe in with anything if you've got any anecdotes or context to add. But so let's a little bit about the technology and some of the challenges, how this looks a little more up close. Why we use a plane and not a multi-copter. I'm sure you guys are familiar with sort of the hobby drones that can hover in one place. A plane versus a vehicle like that can fly much farther for sort of the same size and energy. And obviously, when you're talking about service radius, which is what we talk about, right? We send a zip out, it's got to fly, deliver, fly back. That obviously leads to a dramatically larger service area, which is obviously important detail. That's sort of what the customer cares about, is how much area can you cover. We can fly very fast. The delivery experience is great. Anybody in here ever seen a demo of an Amazon Prime Air drone drop a package? It's one person, or a Google Wing. It's basically, if you're picturing a drone like this, you're picturing the wrong thing. You got to picture sort of 4 lawnmowers tied together, which is, it's a pretty intense experience to have that hover, around you. And this experience is, well, it's kind of magical. The plane just sort of flies by, it kind of pops the package out, and then you have what you need, which is both a better experience and much easier to make safe, much safer. And then these last 2 bullets kind of go hand in hand, but planes are much easier to make robust, which is a big part of safety. So operating in severe wind and weather, and then operating, if a control surface has a problem, we can keep flying. If a battery pack has a problem, we can keep flying. And these are very important features when you're flying in populated areas. As I'll show you a video in a little bit, you can see what we fly over. There's a lot of people there, and you have to do that responsibly. That's obviously something we take very seriously. Yeah, so we launched these planes off a catapult launcher that launched the planes to basically 100 kilometers an hour in a third of a second. We land with this landing system. This is a video of that landing. We don't have enough space for runways to operate where we operate, and we want to operate very fast. And as we look ahead to future distribution center locations, this sort of big open field you saw in that flyover is not what we expect to have at any future distribution center. It's more like being plunked down next to a warehouse building, basically. And so that's where this sort of aircraft carrier onto a bouncy castle, as you'll see why that description is apt in a second. But there's a plane coming in. You can see the wingtip lights out in the distance there. And what you're going to see is the plane's going to fly through, catch a tail hook on a line. The ground system will decelerate that plane and poof it onto a mat. So that's literally made by a bouncy castle company for us, that mat. And it's a very robust system. We've been very happy with it. If there's any issues with, basically if it's too windy or too gusty, and that system you see with the poles and the line doesn't catch the plane will just fly automatically around and come in for another try. I'll let that play one more time just in case you haven't seen how that works. It's kind of fun.
And you'll notice that it's capable of recovering in either direction. So we're able to recover in a variety of wind conditions and always be going into a headwind. There's a mat on either side, and the pole system can swap over autonomously as well.
So here's one more video of a landing. Well, actually, this is actually coming in from the other direction. So one of the things that, as a sidebar, was we were very worried about when we were starting this. So we had no idea what the kind of community acceptance would be like. And you'll see, if I can pause this. Nope. Anyway, I don't know if you noticed that, but off to the side, we have spectators every day who come and watch this and cheer these zips coming in. And it's, in the world of product design, especially when you're doing something kind of crazy like this, you always worry that about these sort of existential things that could really derail you, like the community being really upset with you. And we've had the exact opposite experience. I think one of the most telling things is just sort of colloquially, these zips are referred to as sky ambulances by the people who live there. And so it sort of clicks as to what they're doing and how they're used. For obvious reasons, we were worried that, given how a lot of other drones are used, the negative connotations might carry to this.
And I think it's interesting to note that at any given point, that crowd by the fence is about 50% young children. So maybe they'll get interested in science earlier or in aviation. So it's really cool to see.
Yeah, so getting into some of the challenges that are important for a service like this, one of the big ones that's sort of obvious is the rain or shine piece. And in Rwanda, the next 2 videos sort of highlight what we mean by that. For those of you, in the second video, I don't know, John, if you know the video is coming up. Pardon John's French. But it'll give you a good sense for what kind of weather we're dealing with. I'll go ahead and play this one. So being able to operate in these downpours is obviously really, really critical. So that's a plane getting ready to, basically getting pre-flighted on that launcher. And we fly through rain like that, well, very often.
Rwanda has 2 rainy seasons. There's the lighter rainy season and the heavier rainy season. But from somebody who grew up in California, it's all heavy rain.
Anyway, this next video is I believe from the very first week back in October, the first really big rainstorm that came in, and John dealing with the fact that we didn't quite have everything staked down yet. Anyway, sorry about that, John. I had to play it because you were doing something. But yeah, so obviously, the weather is hard on the zips, but it's also a big part of what we designed for is basically making it easy to operate these systems for the operators in this kind of weather. Literally, foul weather gear is part of our operator's kit to be able to work in these environments. Next video I'm gonna play here is a little 10x speed up. This is a flight to one of our delivery sites, just looking down. And I'll try to narrate through it, but you'll see the kind of terrain we're flying over, the kind of population we're flying over. I think at one point in this video you'll see rain on the lens, and it's sort of representative of well, what these zips are doing every day. So this is probably, I know I said 10x speed up, I think it's actually a little bit faster. I think this is probably a 30-minute flight you're watching in a minute or so.
Do you know which delivery site?
Oroho.
Yeah, it's about a little over 30 minutes.
Yeah. So the plane's flying out. You're going to see it start to spiral. And so what that's doing is losing a bunch of altitude to go make the delivery. You're going to see it come very close to the ground. That's when it's actually dropping the package. Then you'll see it spiral back up to regain altitude, and then it'll fly back to our distribution center, which is when you're going to see the lens get wet. I think one of the intense things about operating close to the equator is there are days when the operations team at the distribution center thinks it's a beautiful day and the planes are coming back soaked because at some point they're going through basically a downpour, but you can't even tell it's raining from the distribution center. And
Rwanda is all a series of hills and valleys, and each valley can have its own set of weather conditions at a given time.
Yeah, there's landed. Yeah, one fun, this is a picture of so what you're seeing here is basically the log data. These are the sort of the tracks, if you will, the GPS tracks from about 5 flights of going out to this, that's a delivery site out in the top right corner. And this is basically the path to this delivery site flies through this mountain pass. And I thought this was interesting to show because you can see, you see the lines get really squiggly through the pass. And these zips are dealing with winds and gusts that are basically getting close to the actual speed these planes fly in these kind of situations. And obviously the zips are fighting hard to actually get through these wind conditions. And there's obviously a lot of engineering work that goes into making these planes robust in all environments, including these kinds of challenges. So another big piece of what we engineer and what we build at Zipline is what we call our air traffic control system. So this is basically the system that enables us to fly a very large fleet of planes with basically one operator flying that fleet of planes. This is a video just to kind of give you a sense. That's 3 zips flying, not intentionally in formation. This is just basically basically this is what they look like when they're flying, and there's multiple up there. These planes are all in the same loiter, which is why the same loiter is the same kind of hold pattern, which is why they look like they're kind of tracking each other. But obviously there's a lot of details that go into managing those zips in the air. Especially, we have buttons that say like, all zips come home now, right? And so you want those to all turn around fly back to the distribution center and obviously not hit each other and land one at a time and all that kind of thing. So there's a lot that goes into that. Having multiple planes in the air at once is very important. And then all of our planes communicate with each other, peer-to-peer, to make that happen. And again, all of these, this part of our challenge, we think of technically sort of 2 big challenge areas. One is that basically making a robust system. that can actually handle all this weather and be very safe. And then the other is the scaled operations. How do you put up this many flights in a day? How do you have this many planes flying at once and do that, and make that easy for these operators to do? And anyway, obviously a big part of that is how do you fly those planes in a very fault tolerant way, right? You might lose a radio, you might lose, this is Outer Distribution Center, we have 3 layers of power backup, but we still lose all 3 layers. We have lost all 3 layers a few times now. And so how do you our system is designed so you can still manage those planes regardless of what's not working. This is just gives you a sense of the kinds of stuff we build. This is we call our controller UI. So this is 3 planes flying over what we call our sky map. This is actually the sky map for Rwanda. And you can see, these 3 planes are all outbound. The operator can dive into one of those planes, pilot the plane, which is what we call basically send high-level commands to a plane, like return to nest. Nest is what we internally call these distribution centers. Go to a hold, so basically go hold its position somewhere and just fly in a circle. Secondary landing, this is part of our regulatory agreement with the Civil Aviation Authority in Rwanda. They have the ability to request that we tell one of our planes to immediately go somewhere and use its parachute landing system to land. And then as a sort of a very last resort, and I'll show you what that looks like, even deploy a chute. But you can see we spent a lot of time making these interfaces super easy to use. So that an operator with lots of planes in the air can very fluidly manage that fleet. This is our air traffic control tower in Rwanda. There's someone getting trained to be a controller. I think it may be the first air traffic control tower that's literally built on a bathroom.
It's come a long way in this picture from the flyover you showed earlier.
That's true. That flyover didn't have the roof on it, which was a key oversight in the early days in those rainstorms. So I'll show you sort of what that looks like. So part of our airspace integration plan in Rwanda has our controller communicating with the air traffic control in the international airport the same way you would if you were in a plane, if you were in a regular plane. And so you'll see here the planes are going to come into land, and you're going to see our controller communicating with Kigali Air Traffic Control. Kigali is the capital of Rwanda, around that flight. That was his first landing. So.
Kigali Airport, Zipline 30 has returned to Rwanda.
So while he's talking, he's got the controller UI on the iPad in front of him. He's got weather data sources up. He can see the status of all the zips and packages that are being packed and getting ready to be flown out. And he's also got live communication by radio with the team in the distribution center in the tent below him, as well as live communication with air traffic control Kigali. So I was talking about safety. This is a really big part of what we do at Zipline is make these zips very robust and safe for people on the ground. And of course, for us, we have sort of a secondary safety goal, which is very important, which is oftentimes, this zip is carrying blood that's intended to be part of a life-saving intervention. And so it's obviously very important that that blood gets there. So we have a very layered approach to safety. The avionics system, the basic system that flies the plane, is fault tolerant to sensor failures and connector and cable failures and propulsion failures and power failures. And there's obviously a lot of engineering and testing that goes into making that actually work. And we wrap that whole fault tolerant, basically flight control system with a parachute landing system. And so anyway, I thought I should play a video of what that looks like. This is a test of that parachute landing system. Basically, once that deploys, the plane's coming down slow enough you can literally catch the plane. Don't recommend it, but someone's done it. And again, that's just we want to have. Well, it's very important to us that these systems are safe for the people who are on them. Yeah, this is when we look to the future, this is a problem that's bigger than developing world challenges. This is from the Navajo Reservation in Arizona. A school bus trying to get to school. There's a lot of places in the States, even in a lot of developing world countries, that also lack the infrastructure that a lot of these countries are struggling with. Anyway, so we're very excited about the future for basically solving this problem completely and universally, of basically enabling any doctor, any patient who's needing the support of a doctor to be able to get the medical supplies they need on demand when they need it. And even in places like in the States, just increasing access to rare, expensive, and of course emergency products is huge. It allows the primary care clinics and these sort of remote secondary facilities to do more healthcare and provide better healthcare, and save the health systems a lot of money by not having to stock lots of things everywhere, especially things that expire. It's very exciting for a lot of these patients in these countries just to have that care close to home. It's a sense of security that in a lot of places, even in these countries and near metropolitan areas, and of course even in the States, we take for granted that you can get topical antibiotic within 5 minutes of most of the places you are. But in a lot of places in the world, even these simple things like topical antibiotic, like they just, if it's not there, it's not there, and you're probably not going to get your hands on it that day even, depending on if it's raining or not. So anyway, a few shout outs. I think one of the things that just kind of give a little more context to sort of what we're up to. This is the operations team in Rwanda. We're approaching the point where the team that we've hired and trained in Rwanda will be running the distribution center completely on their own. This group is quite incredible, incredibly hardworking, incredibly dedicated, and it has completely blown away the team from here in terms of how fast they've taken over the operations of this distribution center. And it makes all of us excited for the future of this in terms of our ability to scale and really solve this at a global scale. One fun little achievement or sort of milestone we hit this last weekend was we went from a 5x10, 5 days a week, 10 hours a day operation, to a 7 days a week, 12-hour day operation. So, just even those little things of going from one shift to 2 shifts, right? And the training required, the discipline required to run a aerospace grade, basically high quality operation like this would not have been possible without this team just absolutely killing it. And people like John taking the time to run our test site in California where we prove a lot of this out and go through all the training to make this happen. One little shout out before I get to the end of the formal part of what I've got to present here. We're always looking for awesome people to join our team, everything from engineering disciplines to operations. We like people from Berkeley and from the UC system. I didn't know this was simulcast, but I would have put some more arrows from, we have, I guess, more than half our team is from UC schools. And as you can imagine, this is a really exciting project to work on. It's really challenging to hit the levels of operational and safety reliability that we're going for. So if you know people who should be a part of this operation, either on engineering, on operations, on manufacturing, we're looking for the right people to grow the team in the right ways. So we really believe in this sort of future of instant delivery. Logistics is definitely moving towards automation and speed. The market is kind of goofy huge. We're actually excited for some competitors to eventually join the space to legitimize it, but also there's no way in the next 10, 20 years we could even solve this problem in the developing world. It's just ridiculously big. It seems obvious when you're working on a project like this, delivering things with 3,000-pound, vehicles driven by people, is just inefficient. We make these deliveries for what in California would cost, about 5 or 6 cents of electricity, which is, you can't drive even an electric car very far on 5 or 6 cents of electricity. And then, of course, what instant delivery brings to the table, going back to the example with blood, using these rare medical products more efficiently is huge for health systems. It can be huge for the U.S. system. It's definitely huge in Rwanda, and it can be a big part of just increasing the quality of care for everybody. So we're really excited about that. So before I close, I want to share one more video, just sort of, this is a flight from earlier this year that returned in the dark, and after delivering blood to a woman who was having postpartum hemorrhaging in birth, during childbirth. So that's my slides, and there's the questions link if you want to type any remotely, but I'd love to answer some of your questions. So I'm going to try to leave that slide.
Thank you very much. I'd like to use the mic so we can record these questions and we'll come around.
There is one question someone already typed, so let's start with that one. Using that URL. What weren't you prepared for once you started doing deliveries in Rwanda, and how did your hardware or procedures have to change? It's a good question. Well, a lot, I guess, is the answer to that question. Part of the reason, we were super excited with our partnership in Rwanda, and the Rwandan government has been incredibly forward-looking. They blew us away from day one with how data-driven they are. In a lot of ways, they kind of, it's almost embarrassing that the government-level decision-making in the health system is so data-driven and sort of logical. It kind of makes the way our government makes decisions seem goofy. So we were really excited to work with them, and we started in October. Trying to think, kind of some good anecdotes to share about things we weren't prepared for. Where to start? Yeah, I mean, we learned some difficult environmental challenges, just simple like reliability stuff, right? Rwanda's got this really abrasive dust that we learned from. We actually tried for like the 6 months before going to Rwanda to smuggle some dirt out of Rwanda, and every person who left Rwanda got it confiscated just because we wanted to test our motors in that, and we definitely learned some lessons that we've now improved our design for. What examples come to mind for you?
I mean, everyday things that you wouldn't really expect. For example, it seems silly, but getting good power strips, with multiple outlets on them, is really hard to do there. The majority of ones you can get are kind of cheap direct manufacture from China, and they're well known for catching on fire at inconvenient times. So actually, just to kind of expand it out, the supply chain between California and Rwanda, we've been sending a lot of stuff with team members as they go over, but just kind of maybe planning out for the next deployment a bit better what basics will not be available there. And that's not to say they don't have good markets, but some things like a power strip or a good permanent marker, a Sharpie, can be really hard to find there.
Excellent talk. I'm a graduate student here at Berkeley, and you showed some great coverage maps of the full range that one vehicle can cover, and you've discussed that you can fly 30 minutes or you have a fleet of 14 vehicles. How modular and swappable are the components on these planes such that you can use those 14 vehicles and keep them in the air as much as possible? Is that currently designed into your system? Do you have plans on including those?
Yeah, so where we are in this, I'd say we did an okay job with this current version, but not a good enough job. And that's actually the focus of our hardware engineering team right now, is the next generation, which is really designed for that field service and that field modularity. This version, we basically deprioritized those concerns for all the other stuff we knew we had to do on day one, like fly in heavy rains and fly long distances and have the fault tolerance we need. But that's where we're headed, we're really excited about being able to. I'd say right now the training for basically a training for what we call a distribution center tech lead, who is basically the head of maintenance at a distribution center. I'd say it's probably a month-long process, maybe 2. We want to get that down to a few days.
We've had the good luck, the good luck of finding really talented teammates in Rwanda, team members, and people with electrical engineering backgrounds, really strong people who could come on and learn the system very quickly. But like Keenan said, that might not always be an option everywhere we go, so having very easy field maintenance is super important for our next model.
You guys are doing really great work. I was wondering, kind of adding on to that gentleman's comments, what kind of modifications do you have to do to the planes you acquire in order to do the deliveries? And then secondly, what kind of different challenges come up when you're operating in the evenings and nighttime?
Sure. So we don't acquire those planes. Those are our own design. Fortunately or unfortunately, there's basically 2 things missing from what's commercially available in drones of this size in the market for our application. One is that most of those drones are designed for surveillance, or basically taking pictures, so they're designed to stay up in the air a really long time, but they're not designed to efficiently cover ground. And so it's a very different aero optimization to make a plane that can efficiently cover ground, getting through wind and rain and stuff like that. So I guess the answer is so it's all our own design, everything from how we deliver the package to the avionics to the airframe itself. A good question about operating at night. There's another question that was submitted electronically. Let me take a step back and kind of the basics of our airspace integration with Rwanda may be a little counterintuitive if you're very familiar with how the airspace works in the United States. So in the United States, there's 2, I'm oversimplifying a little bit, but there's 2 types of airspace. There's controlled airspace, right, which is tower controlled, like around San Francisco Airport, for example. And then there's uncontrolled airspace, which is sort of like crop dusters and stuff like that are generally operating in uncontrolled airspace. They're not coordinating their flight paths with anybody. They're not getting approval to launch and land, things like that. So Rwanda doesn't have that distinction for a bunch of reasons, one of which is it's a fairly small country. So the entire airspace of Rwanda is controlled airspace. So we literally have in the Kigali air traffic control tower and approach sections we're used to seeing like air traffic control views. We have our data there. And the air traffic controllers in Rwanda are monitoring our planes just like they monitor all the other planes in the airspace. It's part of the reason we have this live link from our controllers to their controllers, is that, it hasn't happened yet since October, but it could happen that they would decide another, like a helicopter or a plane is basically on a collision course with our zip, and they can tell us, hey, I want you to hold position or turn around, or they could even tell us to deploy our parachute landing system. So in some ways, flying at night, we actually think of as safer in Rwanda than flying during the day for one simple reason. As you guys saw, those wingtip lights show up really well in the dark. And a small, low-flying zip in sunlight you can't see it as well, just visually. But yeah, and we have regulatory approval to fly at night. Actually, we'll see. We're in talks with the government of Rwanda about extending the service to 24 hours a day. But we'll see if that happens later this year.
Yeah, you partly answered one of my questions, but I was wondering about how the packaging was that for the drones, or I guess you haven't called them drones, but for the planes, and how close you are to your suppliers. Do they package it for you, and so you received the package already set for delivery, and do you run into problems when people? I mean, how is the demand driven for your service? Do your customers call in and say we need this, and then you do it?
Yeah, so that's how orders come in. So just throughout the day they come in, and some days are long, especially when there's emergency orders that come in late in the day. Our team will stay and get those orders done. And you were asking about the package, the little chute.
Yes.
Yeah. So that's something it's the final assembly of that. The chute and the package is done basically, basically as needed in Rwanda by the team who actually takes, does all the blood handling. Okay. And so they pack the packages and they put a barcode on there that tells the flight operators and the software system what delivery site to go to.
Okay. Thank you.
Yeah.
This gentleman, there's a mic coming.
Hi, I saw that video of parachute delivery. It was amazing. It's quite smooth before and after the delivery. My question is, once you drop something from your plane, then the weight changes, the center of gravity changes. Would it be a concern for that plane? Things get basically the flying characteristics changes, or that payload is so tiny you don't care. So what is your point?
Oh, yeah, it matters. And so part of the reason we designed our own planes is that package is very centered on the CG of the plane. So when it drops, it doesn't the weight doesn't shift for the overall plane very much. And then we do a lot of testing and simulation to show that even somehow that blood got like smushed against the back of the package or the front, we can still fly. But that is an important concern because it is, obviously we try to make as much of the percentage weight of that plane be package as possible. So it's a pretty real amount.
And it's also something to consider when we design our battery, because nominally the plane delivers the package and comes home empty. But if something goes wrong and it's not able to deliver that package, it has to return home with that extra payload on board. So our battery design gives us margin for that as well.
Hi, thank you for this very interesting talk. So I had a question about logistics. You said you did import some of the medicine from California, but I imagine it's a different picture for blood. So how does it work? Do you gather blood from centralized hospitals in Rwanda, then gather everything in your own warehouse and redistribute it to remote locations?
Yeah, so we receive deliveries of blood. It varies, but once or twice a week typically, to our distribution center, and we have all the storage equipment and even defrosters for some of the products at that facility. And so we're basically holding enough inventory. At least so far, we haven't had so far, actually, maybe you know otherwise, but so far we've never had a case where we've had an order come in and we haven't had the inventory at our distribution center on hand. But yeah, we maintain that inventory very carefully. And so like literally at the end of every day, there's a conversation between the blood technicians at our facility and the Rwandan Center for Blood Transfusion that manages the blood supply for the country to basically decide, does something need to be delivered in the morning to maintain our inventory, to be sure that no matter what orders come in throughout the day, we think we can cover them.
We have time for just another question or two. I'd like to throw one in, if I may. Could you please tell us what you see as the greatest regulatory barriers, both from the health side as well as the aviation side, not only in Rwanda, but actually for replication scaling in other countries?
Sure. The regulatory landscape is sort of interesting in countries like Rwanda. We benefit a lot from basically, in a lot of ways, Rwanda's airspace is more regulated than ours. Our airspace, basically, we've grandfathered everything in, including like hot air balloons without transponders and things. So in the airspace here, it is essentially very messy, which makes it very hard to introduce something new to the airspace. Rwanda has, well, as they would call it, they've modernized their regulatory schemes over the years, which makes it much simpler to manage and much simpler to integrate a system like this. There's other countries we're working with who are more like Rwanda, more like the States. I think obviously what we're doing has a different safety calculus than sort of typical, basically typical vehicles flying around the airspace for fun or for transportation. So depending on the analysis you look at, we think we're at a point in Rwanda we're already helping save potentially a life a day or so. And that's really powerful, obviously, and it changes the calculus for basically the sort of what we think of as a very low risk from an airspace integration point of view, even with planes like this that, our planes don't have sensors or anything that would see another plane and avoid it. So.
Maybe a couple kind of network sort of questions. The example you gave here is really hub and spoke with round trip delivery, one-way delivery. And thinking at least even in terms of kind of a next use case of sophisticated central analytic facilities to which you want to get specimens that might test the one-way aspect of it. But more generally, you're doing hub and spoke, which logistically is simpler. If you went to a full network, how might that change things? Like say if you got the contract for Amazonia, what might change at that higher, the ATC level and above?
Sure. Well, a lot would change, and I think the part of the fun of a startup like this and getting the first system shipped is you keep it as simple as you possibly can and as directly solving only the minimum set of things you have to solve to really make that customer happy, and that's what we've done. We're very excited about the potential for more complex networks. When you talked about, we have got a lot of customers we're working with they're not as interested in reverse logistics, but getting the samples back, to testing labs as they are about getting medical supplies out, but they're very interested. It's not something we're working on right now. We're very excited about the sort of the new wave of basically very low cost, almost disposable test set up so we can just deliver them out to the hospitals rather than having to bring the samples back. But we'll see how that goes in the long run. But yeah, we definitely have, we've put some time into looking at sort of basically, full network, basically, like you said, moving beyond the hub and spoke simplicity. I'm not sure how soon we'll get there. The demand at this point for just what we have at the simple level is, we could be working really hard for the next 5-10 years and still not have met the demand in terms of scaling this. So that's certainly where our head is at the moment.
Hi, you talked a bit about how you're technically adapting it to make it simpler for the operators to use. I was wondering how else you're looking at sort of what's the next generation looking like and what's driving that beyond just simplicity.
And some of that simplicity we use a lot. So we have a test site here in California where we fly a lot. We're basically we're trying to stay ahead of what we do in Rwanda, so we're flying all day, every day there, and that's obviously where we want to work out everything we can before deploying to Rwanda, including software updates and things. So a big part of what we've developed over the last few years is basically our pre-flight test systems. So these are very automated tests run on every flight that would even catch if someone did some maintenance without then updating a configuration or a calibration. It catches those things across the plane. And so, basically, we're always looking for the sort of where we can provide the most value to enable the operators to work quickly. Because as you can imagine, the demand, if you will, throughout a day is not steady state, right? It's very random. And, there are times when there's no orders for an hour or two, and then all of a sudden, they've got to get 10 flights off as fast as they possibly can. And so anything we can do to enable them to focus on getting the right product to the right customer and not having to worry about the technology they're operating, that's what we're thinking about. So we have already automated control surface checks, propulsion checks. There's a lot of obviously automated, basically built-in features to the Zip itself for auto diagnosis that's used on the ground before flight and of course in flight. And so those are some of the things we've already done.
I think operationally, just more automation as well. Like for example, our controllers now are making calls to Kigali Air Traffic Control, person to person. And when we're at a scale where that becomes difficult or not possible anymore, we'll need to automate it, hopefully before that.
Sure. Yeah.
Well, I'd like to have you all join me to thank, again, Keenan and John on a fabulous presentation, very intriguing. Appreciate it very much.